So am I audible to all of you? Am I audible to all of you? Okay, yes, fine. In the last class, did you complete the numerical? The numerical of the rocker and roller bearing? I think so. We have completed the numerical, right? Can anyone please say? Can anyone please say? Can anyone say? Did you complete the numerical last class? So let us give you a brief. Let me give you a brief introduction on the Foundation. Okay, this is just a brief introduction. So we'll just understand the theoretical perspective of a Whale Foundation. Before that, continuing, I'll just show you a small film, a video of Whale Foundation is done. Okay, can you see my screen? Can you see my screen? Can someone unmute and speak up?
Yes, sir.
Okay, so let us start.
As seen built in the mid-20s of the last century. Traffic. The old bridge over River Yamuna is a nuisance. Today, frequent traffic jams have decided to construct a new cable-stayed bridge parallel to the HCC joint venture. The National Highway Authority of India finalized alignment of the new bridge connecting GT Road on NH2 on the Allahabad side with Rewa Road on NH27 on the Naini side. The total length of the connection is 5.155 kilometers, comprising of 3.5 kilometers of approaches and 1.5 kilometers of actual bridge. The river Yamuna is still extensively used for navigation purposes by local people. Hence, another challenge before NHAI was not to disturb the navigation use of the river. NHAI, therefore, decided to opt for a cable-stayed bridge, as it provides wider navigational passage. For speedy and systematic completion of the work, the entire scope of the work was divided into 4 independent modules. Module 1 contains cable-stayed portion of 630 meters length with central span of 260 meters, supported on double D well foundations with depth up to 40 meters. The approach viaduct of 515 meters length on the Naini side with spans of 60 meters founded on circular well foundations is included in Module 2, whereas the 365 meter long approach on the Allahabad side with 25 meter spans supported on 1.2 meter diameter piles is included in Module 3. Approach road works, which includes embankment works, retaining walls, cross drainage works, pavement works, safety signboards, etc., are included in Module 4. After the center line of the bridge was established with the help of precise surveying, foundation works were taken up. Foundations of the pylons B17 and B18 supporting cable-stayed portion had to be built in the middle of the riverbed, which were enclosed by coffer dams, access to which was provided by jetties constructed on both banks. The jetty on the Naini side is 260 meters long, with double sheet pile enclosure, driven by vibro sinkers. The jetty on the Allahabad side is a timber structure 100-meter long. Well foundations. The well foundation work is executed in the following stages: cutting edge, well curve, staining, bottom plug, and well cap. Cutting edge. The cutting edge serves to cut through the soil strata and facilitates the sinking of the well to the desired founding level. The cutting edge consists of back-to-back angles welded with a 12mm plate bent to shape on the outer periphery. Before the final assembly of the angles, holes are drilled into the face of the angle to receive the bond bars. The cutting edge is placed on timber sleepers after the ground is leveled and center point is established.
Wow. Wow.
Well curve. On the cutting edge, well curve is cast in concrete within tightly fitting inner and outer forms with embedded reinforcement. Plywood formwork of PERI make is used for pylon wells. The concreting is carried out in layers using concrete pumps and transit mixers. Needle vibrators are used for compacting the concrete. The well curve is pitched into the ground by removal of sleepers placed beneath the cutting edge. The dredging inside the well curve is carried out manually. Well staining. When the well curve is partially sunk into the ground, well staining is built in lifts of 2.5 meters and sunk into the ground. Well staining for pylon wells is built in lifts of 2 meters height. The concrete is transported from the batch plant and is poured using concrete pump. For P17 well, the concrete is placed by crane and bucket arrangement. Concreting is done in clockwise direction in layers. The green concrete is vibrated using needle vibrators. Well sinking. Well sinking is an important activity and is carried out with utmost care. The wells normally sink into the ground by their own weight. The soil underneath the cutting edge and in the central dredge hole is removed by using grabs. Continuous grabbing operation is carried out till the well is sunk down to the desired level. In the case of hard strata, chiseling and grabbing method is deployed to loosen the strata, and muck is grabbed out from inside the dredge hole. Care is taken to carry out grabbing in a uniform manner inside the dredge hole. In the case of double wells, the grabbing is carried out uniformly in the outer dredge holes, employing 2 cranes followed by the inner dredge hole. Readings are taken during sinking on the gauge marks to measure any shifts or tilts, which if noticed are corrected by eccentric dredging or by placing eccentric gate ledge loads and carefully monitoring the movement of the wells. Well plug. When the well reaches the founding level, grabbing operations are discontinued and the well is made ready for plugging. Confirmatory bores are taken to study the soil parameters. Concreting of bottom plug is carried out by Tremie arrangement. The Tremie pipe with tightly sealed joints is lowered into the well and a hopper is placed on top to receive concrete. A swivel concrete distributor connected to the concrete pump is placed at the center of the well. The concreting is carried out in clockwise direction, moving from one hopper to the other. Pile foundation. Module 3 of the project, namely approach viaduct on the Allahabad side, is founded on 1200 mm diameter concrete piles. Each pile group consists of 4 piles with a total of 130 piles for the viaduct. The board cast in situ piles are installed using Casa Grande piling equipment, using retrievable casing pipes. The oscillator of the piling machine is placed at the pile coordinates previously marked on the ground. Casing pipes are driven into the ground by rotating the oscillator. Verticality of the casing is checked at regular intervals. As the casing pipes are driven, a tiny grab is employed to remove the muck from inside the casing. When the casing pipes are driven to desired depth, soundings are taken to check whether further boring operation is required. Thereafter, the reinforcement cage is lowered into the bore. Concrete is placed inside the casing by crane and bucket arrangement through a Tremie pipe of 200 mm diameter fitted with a hopper. Concrete is delivered continuously to the bottom of the pile bore in stages of 3 meters. When each stage is completed, the casing along with Tremie is lifted out and concreting is continued up to about 1 meter above the cutoff level. The pile is then chipped off up to the cutoff level and integrity test is carried out to check the soundness of pile concrete. Load testing. The installed piles are tested for the working load capacity envisaged in the design. Tests include 2 initial and routine load tests each. The initial load test consists of vertical as well as lateral loading. The vertical load is applied by a kentledge in the form of jumbo sandbags, each weighing 1 ton, in 9 tiers corresponding to a total load of 850 tons, placed on a platform erected on top of the pile. Increments of 20% of the test load are maintained for 1 hour, and the displacement of the pile is recorded by means of dial gauges. When the final load increment is given, the final displacement is noted, and working load is calculated from load displacement graph. Pile caps. Before commencing the activity of pile caps, all the piles are exposed and chipped off to the cutoff level. 100 mm PCC is laid on the planned area of the pile cap and cured. Concreting is carried out using concrete pump and vibrated using needle vibrators. The top surface of the pile cap is made plain using trowels, and curing is carried out by bonding arrangements. Pier shafts. The pier shafts in Module 3 are of size 1200 mm by 2000 mm in plan with heights varying from 2.5 meters to 7.5 meters and are cast in single lift. The steel forms are made as per the design. When the rebar fixing is completed for the pier shaft, the formworks are placed and aligned for the verticality and center line. Concreting for the pier shafts is carried out through crane and bucket arrangement, and it is vibrated through the needle vibrators. Deshuttering for the pier shaft is carried out 24 hours after concreting. The surface of the shaft is wrapped with Hessian cloth and curing is carried out.
I hope some basic fundamental things are being clear by watching this video. What is actually well foundation and why it is necessary? Yeah. Yes or no? Can you respond? Yes. Okay. Okay. So, what I'll do is I'll show you a presentation. Okay. Wait, give me a minute. On well foundation, let me just give me a minute. Okay. So I hope you can see this. So what is well foundation and cations? So well foundations, these are a brief history about well foundation, since when they are used and whatever. Okay. Now, the main difference between whale and pile is what? Pile is flexible like a beam under horizontal loads. And whale undergoes a rigid body movement under horizontal loads. Now, what are the different types of whales? The types of whales, following are the different types of whales. Number one, circular dumb whale, double D whales, double octagonal whales, single and double rectangular whales, multiple braided hole whales. Now, so these are the different types of whale foundations. Hmm. Now, according to the material used, it can be wood, steel, or RCC. So these are the different figures of the whales, whale foundations. Now, look at this. So this for these figures like this one, this one. So how will actually the cross section look? So these are the different cross sections. In the second, these are the different cross sections. That means this is the plan. This is the section view. Okay, so in this way, the different types of well are being done. Okay, I'll share up this presentation with you. Then we are having what? Then there are the different types of classification of well types. Now, classification of well types on the basis of the cross section. How on the basis of cross section? It is what cylindrical, cylindrical, then cylindrical with enlarged base. So here, if you see here, this is a cylindrical one, but the base is what enlarged. Then you are getting conical like this. Then this is a conical with an enlarged base. Okay, these are somewhat like this. So maybe this is a conical with an enlarged base. Now, according to the cutting edge means just now in the video, if you see, just now, sorry, just now in the video, if you saw, the cutting edge is the bottommost portion of the well, which is actually, which is whose main purpose is to what? Is to drive the well or below. Is to drive the well below. So this is the cutting edge. So that is the cutting edge. So different types of cutting edge. If you see here, this is for RCC. Then this is with outer steel edge. So the diagrams are a bit different, but the main principle is same. Okay. Now, if you see here, the RCC in the RCC, it is made up of reinforced cement concrete, and if the cutting edge is of steel, then the outer edge is made of steel, so that it can be easily driven inside the ground, which is below the water. So this is how the you know what do you call it? The well is constructed. Now, if you go to the next one, these are the advantages of wells. Okay? So these are the different advantages of wells. They are of large diameters and can be extended up to larger depths. Then it has a large bearing capacity. So these are the different, what do you call it, advantages. And the cost of construction. This is the main, important thing. This is very less because you have to see for the cost of constructions. If you see, you know, these constructions, what will happen? It will be like made on the bottom of a river, right? So if these are made on the bottom of a river, then definitely it will incur a large amount of money. It will involve a large amount of money, right? So if this involves a large amount of money, then definitely it will like if the cost factor is not considered, what will happen? If we don't look to the cost side, what will happen? Can anyone unmute and speak up? Can anyone unmute and speak up? Or maybe justify any one of the points? Can anyone please speak up? Yeah, no one? No one? Let us move to the next. So these are the certain disadvantages of well foundation. Now, components of well foundation. So these are the important components of well foundation. So number one is what? Cutting edge. The cutting edge is the most below part, lowermost part. You can see here. Then you have what? Well curve. Then bottom plug. Then sand filling, bond rod, staining, top plug, well cap, pyre and pyre cap. So these are the different components of the well foundation. So we'll be discussing one by one all these different types. Fine. Okay. Now, so this is an alternative diagram for the you know cross section of a well foundation and its different components. So first of all, in a well foundation, if you see here, this is the open type, right? So we'll be having a look at the open cation type well. So this is an open cation type well. Okay. So in this open cation type well, first of all, the first point is what? The cutting edge, we just discussed right now. It is made up of either RCC or maybe what you call it. You know, uh, Steel also. Okay. So this is the lowermost end of the open or pneumatic cation for accelerating the what? Sinking operation. That means the well is required to be sunk, right? If the well is required to be sunk, then what will happen? If the well is required to be sunk, then you have to use certain sharp edges which will help in sinking of the well, right? If like this is the cutting edge. You can see here. This is the cutting edge, right? Now, if this is the cutting edge, so this is the one which will facilitate the well to sink. Now, its angle is to the vertical is 30 degree and normally one horizontal, two vertical given the slope. In concrete questions, the lower part of the cutting edge is rigidly fastened with 12 mm steel plates. The cutting edge should be sharp. This is all. A sharp vertical edge is generally provided to outside face of the question. Now, well curves. A well curves is the next part above the cutting edge. Now, in the cutting edge is required to be attached to the other part of the well with the help of certain tools, right? Or maybe with the help of certain structures, right? So if it is required to be attached, so how will it be attached? It is attached with the help of well curve. Then there is what? Bottom plug. Now this bottom plug is what? After final grounding of the well to the required foundation level, a concrete plug is provided. The bottom plug transfer the entire load to the well. So the bottom plug is the main structure which is allowed or which is mainly used to transfer the entire load to the ground. The bottom plug also functions as an inverted dome which is supported along the periphery of the staining. Okay. And as it is not feasible to provide reinforcement at the bottom, it is generally made thick and a rich concrete mix and plenty is used. The bottom plug, look, this bottom plug is what? Suppose here, if you can see here, this is a mixture of concrete. Actually, when the cutting edge and weld cup, when the load is placed and the weld is allowed to sink, maybe on its own weight or maybe on. Now, what will happen if this is all sand below? Then definitely it will be causing a problem because that sand might get washed away, or maybe the sand will not be stable because of the scouring effect, right? Now, if this happens, then definitely this well will sink and eventually it will cause the sinking of the foundation of the bridge. That is why this bottom plug is provided. Now, this bottom plug is provided like inverted dome. You've seen a dome, right? It's like a bowl. If it is inverted, it will look like this, right? If it looks like this, then what will happen? This will facilitate the stability of the structure and will prevent this to sink below a certain permissible limit. Fine. That is why it is made up of rich concrete and generally a mix of N20 is what used. After curing the bottom plug, the well is filled with sand in saturated condition. And we will provide what sand filling because after the bottom plug, because the below there is concrete, right? If there is concrete below, then you can just fill up above it with what sand and all, so the whole wall becomes stable, right? So this is what is done in sand filling. Now, if you can see here, next is what staining. Staining is constructed in concrete or masonry wall. Use of staining is to provide what dead load during sinking operation. Staining is basically that it is used to provide what dead load during sinking operation. That means this staining is made up of concrete. That is how the well will sink. No? If you saw in the video. So in this way, staining is provided. Now after that, what is there? Topping. Topping is the what? Covering that is provided on the well casing. If you can see, this is the top plug. After staining, this means this is filled with sand, no? This part. Now once this is filled with sand, there will be a certain stage when it should be covered with concrete. Or maybe what? The well is sealed completely so that it is not being sunk down again below that permissible level, as well as what? It is the top level of the well cap. That is why the top plug is provided. Like above that only you will be providing the well cap, right? Below which the pier will be constructed. The top plug is what? Provided after filling is completed. Now, after filling, just now I said top plug is provided. The top plug is what? It is helping in transferring the raw load of the pier and the superstructure to the staining. The thickness of the top plug is generally kept greater than 50% of the smaller dimension of the bracing top. The sand filling is used. The top plug is simply constructed using PCC of 1:2:4. This is what the ratio is all. Simple. This is how the top plug is actually. This is the basic principle. Now after that, you'll be providing a well cap. The well cap is the what? It is the mediator or mediating layer that will what? Help in accommodating the pier. That is the main pier of the bridge. It should stand over something, right? So it is that base. The well cap is that base above which the well pier, the pier of the bridge is basically constructed. Okay. The center of the well cap is made to coincide with that of the pier. But this is an important point. Okay. So basically, these are the components and its explanation. So my voice is cracking. Oh. You just try to. I hope this is clear for every one of you. I'll just send you the PPT after this whole thing is over. By the next class, we'll be completing this thing. Then we'll go to the last part, that is earthquake. Okay. So earthquake won't take much time because you all are aware with the earthquake. I hope all of you have the IS 1893 and 13920. I hope all of you have this IS codes. Do you have 1893 and 13920 for earthquake resistant design structures in your final year projects? Yes. Okay. Fine. Good. Now what we'll do is we'll discuss about it like basic terms of earthquake, what is earthquake, everything, the basic concepts, and there will be one or two small numericals. That numerical only that you do for the earthquake analysis part, that will be in the form of a numerical. So this is how we'll do it. It will hardly we can start it after we finish this. I'll just give you some introductions about this well formations and all, and once it is done, we'll just go to that part. Okay. So now what we'll do is